Okay, so we're going to be watching a quick video here on factoring polynomials with a GCF. Emphasis here versus what we've done before is specifically the GCF part. Okay, so this means that the problems we're going to do will have a common factor that should be divided out before we start the problem. This is incredibly important when we get to the diamond problem and the rectangle part, because it's going to make the diamond problem much larger, and it will also make the rectangle more difficult because there'll be more than one way to solve it, which is not what we want. So like I said, we're going to jump straight into examples. So the first example we're going to look at is 12x squared minus 54x minus 30. So let's take a look at this problem just in general. Okay, as you can see, 12x squared will go in the upper left corner and negative 30 in the bottom right. Now, forming our diamond problem, the top is going to be 12 times negative 30, which is negative 360, and the bottom is going to be 54. I don't know about you guys, but I can't think of the two numbers that multiply together to equal 360 and add up to equal 54 right now, off the top of my head. And this is why certain problems like this require us to use what we call a GCF, which is a greatest common factor. We have to ask ourselves, before we start the problem, before we do all this work, what is the largest thing we could divide out? Because what you got going on right now is you got an extra number in there. That extra number happens to be 6. Okay, what that does is, because there's an extra 6 in all three of the numbers, you end up with an extra 6 here, and an extra 6 at the end. And what that does is, when you multiply them, it actually makes the top 36 times larger than it should be. So you're going to see when we simplify this problem, it becomes much simpler. You can go ahead and figure the numbers out, and at the end it will work out, but for me the difficult part would have been coming up with the negative 60 and the 6. That part would have been the tough part for me. And now when we write our factors, we get to here. What I want you to notice is that this number right here, okay, has a common factor in it. There's a 6 that could have been divided out, and that 6, instead of dividing it at the end after we've done all the work, should have been divided out at the beginning. Now we're going to go back to this step again, and this time what we're going to do is we're going to do the same problem, but we're going to do it a different way. So instead of 12 and 6, we're going to do 2 and 6. And what you'll notice is it still totally works. That's a problem. Okay, you shouldn't be able to do problems more than one way when we do these factoring. And the reason we're able to do that is because of that extra common factor. Looking again, 2x plus 1 has no common factor, but if I look at the right side again, now I've got a 6 that would again divide into the problem. And that extra 6 is our issue. So what we're going to do instead this time is we're going to say, hey, wait a second, what would go into all three numbers? And we need to do that right at the beginning. It turns out 6 is a number that goes into all three, which means we can go ahead and write the problem as 2x squared minus 9x minus 5, which when we factor it, we just leave that 6 on the outside. Because when we're talking about factoring, that's still factoring. We're just factoring a GCF out, which is just a common number. One thing I want you to think about too as we start this problem, that way, is even if you didn't see that. So even if, let's say, you saw the problem and you saw 12x squared minus 54x minus 30, and you didn't see that a 6 went into it. Maybe you only saw a 2 went into it. Well, what would happen is you'd get 6x squared minus 27x minus 15. Okay? And from there, you could then ask yourself, does any number go into 6, 27, and 15, which of course a 3 does. That 3 then would have to go with the 2 and would create a 6 for the outside of your parentheses. So you don't have to do it in one step, but if you start with the largest number and work your way down, which is what I find to be the best for GCF, is start with the smallest of the three things and look for the biggest number that divides into that. So for example, this one had a 12, a 9, 54, and a 30. So I would start with 12 and think about what things divided into 12 starting at the top. Asking myself, does 12 go in, does 6 go in, etc. From there now, we're going to go ahead and just write that 6 down at the bottom. And we're going to go through our normal diamond problem and rectangle process. Okay, and I'm going to do this quickly because we've done it a lot of times. On top, you're going to have negative 10. On the bottom, negative 9. Just think about this. Before, it was negative 360 on top. Think about the difference there. On the sides now, we'd end up with negative 10 and positive 1. And now when we make our diamond problem, there's only one way to do it right. It has to be 2x and x. It has to be -5 and +1. And when you go to your final answer, there is no number that divides into 2x plus 1, and there is no number that divides into x minus 5. That tells us now we have completely factored it. So as you can see, the GCF really just made the problem a lot simpler to come up with the numbers, and at the end we had nothing left to do. So we're going to look at a few more examples, of course. Starting off with this one, you should just be asking yourself, what number could I divide into all three of those? Remember, don't check 60. There's a lot of things that go into 60. 12, 15, 30, 20, all those things. 5 is the smallest number, therefore that's going to have the least amount of things that go into it. So ask yourself, what goes into a 5? Well, the only thing that goes into 5 is 5. So what I'm going to do is I'm going to divide 5 out of all three of those pieces. What that's going to leave me with is x squared plus 7x plus 12. And again, that's by taking all three parts and dividing by 5. Now I do my diamond problem with what's left in the parentheses only. So I go ahead and do my diamond problem in my rectangle, which is going to be 3 and 4. And from there, the rest of the process is just exactly what we've been doing the whole time. And we're done. So these things will get faster for you, but the key to this video, the key to this lesson is to look for that GCF. So as soon as a problem pops up on every single problem you ever do from now on, every factoring problem, and even things we're going to do later, look for a GCF. So again here, think to yourself, which number am I going to check? Hopefully you're thinking I'm checking 8. It's the smallest one. The only things that go into 8 are 8, 4, and 2. So start with 8. Does 8 go into 20? Nope. Does 4 go into 20? Yes. Okay, does 4 go into 28? Yes, so therefore 4 is the GCF. That's the process you need to do. Don't start with 2, because of course 2 goes in, because if 4 goes in, 2 goes in twice. We want to start with the large numbers. Okay, now we rewrite it without the factor, and we do our diamond problem. And just remember as you do this, that what the whole advantage to this is not just about, saving ourselves steps, because really we could have factored out the 4 at the end. We saw that with the example where we didn't do it. The issue is that our problem would have been much larger on top. Instead of 14, it would have been 16 times 14 on top, which is a large number. I don't even know what it is. Now we have our factors, and we're done with the problem. Again here, looking, you can see 2 is going to be the only number that goes in. Which means we're going to make our diamond problem. And solve for the outside. Each time, remember, you can check your factors. Does anything go into 3x plus 1? Nope, because 1 is a prime number. Well, not a prime number, but 3 is a prime number, and 1 has nothing that goes into it. 2x minus 1 also is what we call a prime factor because nothing divides into it. Okay, now this one might be a little bit different for you. You're probably looking at it thinking, I can't think of a single number that goes into any of these. Well, there isn't. But what there is there's an extra x hanging around in there. As you can see, we have x to the third, x to the second, and x. Because you're in Algebra 1, you should not expect to see anything that has any power higher than 2 in terms of stuff you should be able to actually do with it. So when you see that 3, that's a clue that you're supposed to divide that 3 out, that extra x out. When you do that, you're going to be left with x squared plus 9x plus 8, which really is just a pretty simple, normal style diamond problem. One of the good things about these problems is that they actually tend to be a little bit simpler because you're taking out a GCF is what makes the number large. So once you factor them, a lot of times they're really easy examples of what we do in class every day. As you can see, the factors turn out to be pretty simple after that, and you're done with the problem. Okay, and that gives you an idea of sort of what factoring out a GCF looks like. Just remember that you want to check that on every problem because all you're doing is making the problem more difficult for you. And in addition, at the end, if you do not take it out at the end, it doesn't have to be taken out at the beginning, but if it's not taken out at the end, it's not factored completely. This problem is not factored completely if you leave that extra x in there. And when the whole point of the problem is to factor, that's kind of an issue. So hopefully this helped you guys out and got ready for your final and your final homework portion. And go ahead and check the next video if you need to.